sovereign AI nation. Today, at India AI Impact Summit, we are celebrating a vision that is coming true, and I'm sure that's very well visible at the exhibition place on what India and other nations have achieved using AI, building it in their own nations. In today's agenda, we have 4 distinguished speakers from NVIDIA who are going to talk nothing about GPUs or coding, but they are going to talk about what is the blueprint to touch billions and build nations, be sovereign AI nation. We'll focus on 4 critical pillars. 1, how to build AI sovereign factories. Followed by that, once we have the factories, how do we churn intelligence out of it, thereby making it more localized for the nation to consume it. And in today's context, of course, because we are speaking in India, we will take India-specific examples on what India is trying to do. Lastly, we will see what scaling of AI across industries like finance, healthcare, manufacturing, agriculture, and so on and so forth, which touches our life on a day-to-day basis, is transforming fundamentally using AI and being more sovereign with this journey. The journey from the conversation of last 5 years that has become reality today is what we are going to see through it, the lens of these 4 speakers. So without taking much of time, I would like to first introduce my first speaker, Mr. Pradeep Gupta, who is the Vice President of Solution Architect Engineering team. He is going to help us learn and show you how to build these AI factories and what learnings we have from the worldwide deployments that we have done it. Pradeep, I welcome you to the stage. Thank you. Small housekeeping stuff while he settles down. I would request each one of you to keep your phones on silent, and we will have the Q&As towards the end of the session. Thank you. Over to you, Pradeep.
Thank you, Jigar. Hello, everyone, and namaste. It's always feels good to come back here and talk about. I studied here from Indian Institute of Science, worked here many years before I, moved out of India to US and working at NVIDIA for many years now. It's my privilege to be here, and I really would like to thank all the organizers for having NVIDIA, giving this opportunity to present. Without any further delay, let's talk about AI. The first part of the AI, which is like how AI is a 5-layer cake. You might be seeing the AI is creating a lot of intelligence. Every intelligence which is being created requires energy, power. The first layer in the cake is power, energy. You need a robust ecosystem of your power, of your energy grids to ensure that when you're thinking about this AI as a part of your strategy, the first layer is well taken care. Okay, moving forward, the second is really about the chips. As many of you know, we have been doing the general purpose sequential computing over many, many decades. But with AI, it's no more the case. The entire world has moved to accelerated computing. And that's what the second layer is super important, GPUs, chips. The third one is the infrastructure, because AI is a full-scale computing problem. You are not just trying to build a new chips. You are trying to build the entire system. You are trying to build the data centers. How do you go and run this at the scale? You need AI infrastructure. We combined all 3 of them, as you can see, and we call that as AI factories. And I'm going to spend a lot more time today talking about the AI factories. And finally, the 2 more layers, models and the applications. Models, as you know, we have a large amount of the data. You can train your models on that. And a lot of these models are not just the frontier models, but they are also available in the open source. And these models are not just the generic models, but they are also domain-specific models. I will have my colleague John later on coming and talking about a lot more about the models. And finally, the applications. Because at the end of the day, you need the applications which can go and take advantage of this entire AI ecosystem which we are building together, right? So applications. Again, John will cover more on that, but let me little bit more focus on the AI factories. The first fundamental thing comes, hey, why we need to go and build the AI factories? What's actually happening in this space? And this is a good way of thinking about. There are three fundamental scaling laws which is driving the demand of these AI factories. The first one, what we call as a pre-training. You have a large amount of the data, and you train your models on that. You might have heard of like Llama and then Gemini, and a lot of these models which were created, you do a lot of pre-training. The second, once you've pre-trained your models, you need to think about post-training. Means you are taking those models and fine-tuning using the techniques like reinforcement learning to ensure they are fine-tuned to do some very specific things. And then finally, the third one is what we call as a time test scaling. What does it mean? Now when you are having these models, can you also reason through them? You might have heard of with the DeepSeek or a lot of reasoning models, which has come in the last 2 years. During your inference or when you're deploying, you are not only just giving the straight answer, but you're reasoning through your answer. And that's where the third law of the scaling comes. But interesting part, as you can see, this flywheel where you have these three scaling laws, which is really driving a demand for a lot of computes. And I will talk a little bit more about with the pre-training to post-training to test time scaling is actually driving a lot of compute demand because you need to generate a lot of tokens. But with this, what these tokens are, they are generating the intelligence. With the intelligence, you can drive more adoption, and that's actually becoming the profit. And once you have a profit, or you have this business outcomes, you can go and invest back into the three scaling laws. That's the flywheel which is continuously running. Another very important part of designing the AI factory is the extreme co-design. As I talked earlier, AI is no more just a chip problem. It's not just a system problem. It's a full-stack computing problem. And when you're thinking about the full-stack computing problem, you think innovation at every layer of the stack. And that's what the extreme co-design is all about. So all the 5 layers which I just shown earlier, you think about how do you go and build the infrastructure where you can innovate at every level. Your compute, your networking, your storage, and how all these compute nodes are connected to each other within a single rack, or how these racks are connected to each other in a data center. And even don't stopping there, how these data centers are being connected with each other. How you go and scale. So what we call is like 3 things here, as you can see, the scale-up design. We have recently we had GB200, NVL72, where you have a 72 GPUs on a single NVLink domain, means each GPU can talk to another GPU at full speed, and you can think of all these 72 GPUs as kind of one single large GPUs, right? That's what the scale-up means. Now you take a lot of these, the scale-up units, and then you go and start scaling out. You connect them through Ethernet or the InfiniBand so that you can scale it. And we didn't stop there. We took it even further when we talked about how you can go and connect these data centers which are at the different locations so that you can have what we call as the scale across. Okay, is my slides working? Wonderful. So I just talked about the extreme co-design, but let's just understand why we are talking about AI factory and extreme co-design, how actually this field is evolving. As you might have seen in the last couple of years, there has been a lot of innovations are happening in the generative AI space, in the LLM space. There's a lot of reasoning models are coming, and which is really driving the amount of the tokens which you need to produce your output, right? Some of the recent examples, I hope all of you are very well familiar with the DeepSeek movement, which happened like probably year and a half back. And then Cuban came, and some of the latest one like Kimi K2, all these models, which is based on what we call as a mixture of experts reasoning models. What does it mean? The MOE models, they basically has two things. One is they are using the reasoning to drive, during the inference time, so that they can reason through the things. And when they reason through the things, it actually generates a lot of tokens. And when it generates a lot of tokens, means you need to compute, and it requires a large amount of the compute. The second and very important thing, in the mixture of expert models, generally you have like many experts. But at any given time, you don't need to go and use all the experts for processing a specific token. What you can do, for example, the Kimi K2 example, which I was talking about, you have a 384 experts which are available in that, but at any given time for a given token, you might only be having 8 of those experts. But very interesting part, if you see what's happening, all of these experts need to go and talk to each other. They need to share and exchange the things. And that's exactly why it's super important. There is all-to-all communication should happen between all of these experts. That's why AI is not just a compute problem, it's also a networking problem. Because if you cannot efficiently communicate all these experts to each other, you cannot get the scaling as I just talked about in the last slide. So the key takeaway, which I really would like to have all of you, from this slide is, think of, with the reasoning models, there's a lot of tokens are being generated. We are trying to becoming more and more efficient by employing the techniques like mixture of experts. But even for that, you need very efficient communication to make it even better and driving the token economics. Because at the end of the day, if you take the dense models and you run it, you actually, it's becoming pretty expensive. And that's why the techniques like MOEs, and where you having only a subset of the experts, generating those tokens, helping you to drive the efficiency and the cost down. Let's look it through from the lens of how the AI has evolved. Because we talked about this extreme co-design and what is driving that extreme co-design, some of the reasoning models and the token economics we just talked about. But think of the evolution of the AI. We all remember that AlexNet movement long time back. And after that, a perception AI era has come up. Many of you know that as like deep learning, where you can go find, detect, and see, hey, this is what a picture of cat looks like or a dog looks like, right? That was a very basic starting point for your deep learning. When the generative AI come up, you added the creativity to your perception. With the next level is the agentic AI, where you not only added like creativity with the generative AI, you now added the reasoning capabilities in your models. And where we are heading next, we are heading when this AI can actually take the physical form. And that physical form, what we call as a physical AI. We believe everything in the world which moves will be autonomous. It means there will be AI in every aspect of our life. And physical AI is going to be the next era where you will see a lot more demand for this compute, and this all new innovations across the full stack is needed to drive what physical AI will need. And this is not far away. This is already here. Okay, so with that, let me also a little bit talk about some of the insane demand of the AI computing which is happening. And a very simple way you think about, if you see on the left-hand side of this chart, there are the model size. If you see just from 2021 to 2025, just in 4 years, it's almost growing 10x parameters per year. Like, models are becoming very, very large. Models are the second very important thing which is happening. The test time is scaling the thinking part. It means you need 5x tokens more every year as we are, moving forward. A very simple way of thinking about, hey, why we need like more tokens in the reasoning and the thinking, because I will give you a very simple example. Just imagine you have 5 people or 8 people, you want them to sit on a dining table. And hey, I have this people number, like I have these 4 people who will not sit next to each other. I will have these 2 people who would like to sit opposite to each other. Basically, you figuring out the seating arrangement. What a general LLM or the model will does, if you give it, it will just give you one specific seating arrangement. But it actually not thinking through all the conditions or all the reasoning which you just have given that. In a reasoning model, it will think through all of those permutation and combinations and figure out the right seating arrangement. It means the amount of the tokens, which earlier you might be needing, let's say, I will just make a number here like, 400 tokens, you might now need, let's say, 5,000 tokens to solve the same problem, but you will get higher accuracy and the better results out of that. So that's the way you can think about why you need more, like with the more reasoning models, you need more tokens per year. And finally, the token economics, which I talked about. If you see in the last couple of years, the cost per token is actually going down very significantly. And the reason for that, and that's what like I was mentioning earlier, the extreme core design is so important, because it's not just how is the next chip is becoming faster. It's about how your entire AI infrastructure is becoming faster. How is all those 5 layers I talked about is having the innovations so that you can drive the cost down of running AI. Okay, with that, we have been building these AI factories for last many, many years. I remember we were having some AI factories in very early days where you have like tens of thousands of GPUs. Today, I'm talking about AI factories where you have hundreds of thousands of GPUs or even like somewhere even like millions of these GPUs working together to solve these problems. We have a lot of experience, and then one thing which I would like all of you to think, hey, how the data center design, how this AI factory is completely being redefined, the traditional way of doing it in the past. A couple of the key points here, like as you can see, traditionally the data centers, they were always designed with a mindset of consumption-based, right? You need to go and consume whatever the infrastructure is available. There is a lot of tools, and you have employees or you have people who will go and use those tools. While with today's AI factory, they are completely value-focused. A very different way you may also think about data center used to be an OpEx for most of the IT organizations. Now data center is, because it's an AI factory, as a factory you produce something, and that the production you can go and monetize. So it's no more an OpEx for you, right? You are really creating the value out of that factory in the forms of tokens. The second very important thing, the entire world, because as I talked about, we were using a lot of tools, and it was all about data retrieval, right? You have the SQL databases, you're just going and retrieving some data. But with the AI, you don't need to retrieve, you can generate the intelligence. And that's a fundamental shift the way data centers has been designed in the past moving forward. Of course, you cannot run AI on x86 CPUs. It has to be accelerated computing, right? The rack design, I remember when I started my career probably 20 years back, having a 20 kilowatt rack was like, oh, that's pretty good, a lot of power. But today, with so much power efficiency and so much dense compute, you need much powerful racks. Generally, seeing a 130, 150 kilowatt of rack is very common in today's data center. And the traditional data centers were always air-cooled, and now you are also looking from air-cooled to the liquid-cooled part. right? And finally, I talked about it's not just the compute, you also need to worry about the networking. With that, I would like to show you what this entire AI factory looks like, what we as NVIDIA have been building these AI factories across the world, across the different countries, and what's that full stack looks like. As you can see, the full stack starts from data center, which is like just your space, power, and cooling, right? You need a space, you need a power. You remember the first layer in the cake, energy, right? And then, you need electrical and plumbing. The second layer is like, you need those systems. These systems, we are working with almost every major OEMs. Pick your OEM of your choice who's designing these servers, or any ODM, and you can go and take that. And then everything in the green, as you can see, there's a lot of compute, the networking, and then a lot of infrastructure management software, a lot of AI software, and a lot of what we call as blueprints, which is a reference example how you can go and build some very specific end applications. John will talk a little bit more about the NVIDIA AI Enterprise and the blueprints. But very important thing, as you can see, it's a mix of the green and blue here. What does that mean in this slide? NVIDIA is a full stack AI computing company. Our stack is open, modular, and flexible. It means we design this stack in a way where we can bring in the entire partner ecosystem to come and be the part of this AI journey. So everything which you can see blue, for example, we work with almost every storage provider here. We work with a lot of our partner who can go and deliver this infrastructure and also manage this infrastructure for you guys, right? We also work with a lot of people who providing like this plumbing and then cooling and then like data center designs. So think of at every layer which you see it here, you will always find there is an ecosystem exists around that. Because we believe AI is a problem. AI is something which will require not just NVIDIA, each and every one of you, not only in this room, but every part of the world to be contributing to, right? And that's why this platform has been designed with that kind of the mindset. So with that, the key takeaway is really, how do you go and think about the next generation data centers with AI factories in the mind, and how do you think about how you are getting ready, how you are making your country, your business, your applications ready for this next wave of the industrial revolution, which is what NVIDIA is driving towards. So with that, let me hand it over to my colleague back, Jigar.
Thank you, Pradeep. Thank you so much. Thanks for that insightful on how to build these factories at scale and why they are so important. And what they are trying to do today in the world with our learnings is what Pradeep was able to share it. Thanks for that, Pradeep, once again. I would now like to invite John, who is a Vice President for our enterprise software. John will be covering up what these factories, once they are built, how to get the intelligence out. While Pradeep tried covering the fundamentals of how the building blocks are, let John help us to cover how these layer needs to be built on top of that so that they can be used in action for this agentic AI world that we are talking about it. Welcome, John.
Thank you. There's really no reason to leave. It's going to be really exciting. I'm just kidding. You can go. You can go. So I'm John, and I'm going to spend a few minutes talking about the upper layers of the AI factory. So as Pradeep spoke about, he spoke mostly about the hardware implementation, the infrastructure, the shell, the power, the GPUs. I'm going to talk up the stack, where the infrastructure is built out and led by both software and storage. We're going to talk about models, many questions about frontier models versus open models, in particular in a sovereign environment. And then we're going to end talking about applications, right? And so when you think about models, they're not just LLMs. There's visual language models, there's world models, there's many different types. Specialized language model is another word that I'm hearing, or another acronym where SLM is used for specialized versus small. And then, of course, all the applications themselves, to be an AI-enabled application, is really to be an agentic application. So in order to enable this, we need to look at the transition that's going on in the industry. So there have been investments in enterprise data centers for the last 30 years to run enterprise applications. ERP, CRM, websites. We even got crazy and did some mobile apps as part of this, right? But they're all about applications that are static, they're pre-recorded, they're coded, and they run. And they do the same thing every time. What we are seeing is a fundamental shift of moving from a data center that runs an application to an AI factory that generates intelligence. And so as we make that shift, you start to see this foundational move of electricity in and data out. And that is true whether you're an enterprise or whether you're looking at sovereign AI for your country or your organization. And so to make that happen, you need two tightly coupled platforms. You need a compute platform, and you need a data platform. Again, if we think of traditional data centers, they were separating the compute from the data. In fact, they even organized, welcome, come on in. They even organized the IT organizations. I only look at compute, I only look at storage. When you think about an AI factory, it's exactly the opposite. You need to have these tightly coupled platforms from compute and for data that are connected with high-speed networks. Data is the fuel for AI. And we'll talk a little bit more about an AI factory, and we'll talk about an AI data platform. And this is nowhere more evident than in the case of sovereign AI. Because what is sovereignty? It's about you, your country, your people, the data that your people generate, your language, your culture. All that data needs to be connected to the AI factory at the speed of which agents think. And so to be successful with your enterprise AI factory or your sovereign AI factory, it's important that you focus in on the use cases that are most relevant for what you're trying to accomplish. So for example, if we happen to be a AI company who's building rack-level, multi-chip AI factories, for us, implementing AI, we focus first on what's important, i.e. chip design. So we use AI to design our chips to be more efficient, to be faster. We also use AI for software development, right? As we co-design our systems from the chip level to the software level, we use AI to assist us. And then because we're building such complex rack-level co-design solutions, we need to really align across our supply chain. So we use AI to allow us to view our supply chain, to communicate with our partners. And then, of course, like every other enterprise, we're going to use AI in every functional area, right? Jensen likes to talk about the fact that we let 1,000 flowers bloom at NVIDIA. We use AI in every facet and every function within the company, whether that's HR, finance and sales, employee productivity, it's everywhere. Now, for a sovereign AI deployment, maybe you replace chip design with something that's important to your country, like healthcare. Maybe you don't focus in just on software development. Maybe you focus in on education across the nation. And you don't just focus in on your supply chain. You focus in on your smart city. You focus in on transportation. You focus in on your utilities. So again, the idea around being successful with an AI factory is identifying and prioritizing what's going to benefit your organization the most, whether you're an enterprise or a sovereign nation. And so What does it take to deploy an AI factory? Pradeep talked about it from the hardware and the infrastructure perspective. What I want to talk to you about is how NVIDIA is working to assist you in building out an AI factory from a software perspective. And you can think about, because we're in tech, there's always a layer cake or a platform, even within a layer cake or a platform. It's the way we think. So it all starts with having the compute and storage that we spoke about, but also having an orchestration layer based around Kubernetes, having the correct software to allow you to create workflows, to allow you to organize your data, and to allow you to observe your AI factory while it's running. And then lastly, you need the agentic infrastructure to drive your applications. And I will spend some more time on models and agents as we move forward. From a sovereign environment, you would use this exact same stack, but you would spend a little more time at the lower levels of the stack looking at how you can implement the AI factory, how you can ensure that you have the connectivity, that all of the networking components are aligned, right? And so NVIDIA is not only helping with an architecture, but we're bringing along with us a whole ecosystem to help you be successful, right? So it starts, again, like everything does at the bottom with the hardware level. So we work with all of the major system providers globally to provide the hardware that's certified, that we know will operate and perform at the level that you need. NVIDIA, of course, provides a number of different software capabilities, from CUDA libraries, through models, through the blueprints that Pradeep mentioned. However, we also validate a broad ecosystem across all the different aspects that I spoke about for an enterprise AI factory or a sovereign AI factory. That provides you not only with an easier path to getting your AI factory up and running, but also the choice that you require. And if you need assistance, we have partners that can help you. We work with all of the service providers and global system integrators like Accenture, Deloitte, EY, and of course the local ones, Infosys, Wipro, Tech Mahindra, TCS. Pretty much every GSI that's out there is here to help you. Whether you're building an enterprise AI factory, whether you're building out a GCC, or whether you're building out a sovereign AI factory. When you operationalize an AI factory, it also changes the metrics that you think about. So in a traditional data center, right, you think about like virtual machines and networking. When you think about an AI factory, your metrics are really about how efficient your agents are, how your system is up, the number of tokens that you're generating per second, the cost of those tokens, and we'll talk about that in a little bit as we move forward. So that's the AI factory, that's the compute side of it. As I mentioned, you also need an AI data platform. So data is the fuel that drives the AI and drives the agentic applications. And so we've created, working with partners, an AI data platform that looks not only at structured data, but also unstructured data. So again, if we compare a data center to an AI factory, a data center typically has, traditional databases, SQL databases, columns, rows. When you start looking at AI, your data comes in many forms. It comes in the form of PDF, it comes in the form of video, it comes in the form of audio, right? It's very much multimodal. So we need to be able to deliver in an AI data platform structured and unstructured data at the speed of which agents think. And again, we're not leaving you on your own to do this. We have a blueprint, a reference architecture for how an AI data platform works, how it ingests the data, how it takes that data and makes it AI ready, whether it's in the form of a RAG with semantic search. It's multimodal, so you can do semantic search on text, on video, et cetera. And we build this out, again, with all of the major storage partners. Right, so whether it's IBM, Dell, VAST, DDN, right, any of these partners, NetApp, we work with all of them, VAST, all the partners to deliver an AI data platform that feeds your AI factory. And again, from a sovereign perspective, this is all of your sovereign data. It's your culture. It's your language. It's your healthcare data. Everything, of course, in a secure and privacy-protected manner. So now we understand the AI factory and we understand the AI data platform. The next level in our 5-layer cake is the models. And we're often asked, should I use a frontier model or an open model? And of course, the answer is you should use both. You should use a frontier model and an open model. They're different tools. They do different things, right? If I want to hammer in a nail, I use a hammer. If I need to put in a screw, I use a screwdriver. I'll admit, I've used a hammer on screws every once in a while. But generally, you want to pick the right tool for the right job. And if you look at these diagrams, I know they might be a little bit small, but the diagram on the left shows how open models are catching up to frontier models in terms of intelligence. So that's the slope of the green line. So you can see open models are moving at much faster and are catching up. And then if you look at the usage of it, which is the chart on the right, you can see from Hugging Face, right, that 80% of startups are building on open models, right? And these models, 1 in 4, if you've ever used OpenRouter, it's a website where you can go to use models. 1 in 4 of the OpenRouter tokens are being run by open models. And as you can see from the slide in the light purple, more and more it's moving to reasoning. That indicates that agentic AI is on the rise. So again, it's not a question of frontier or open models, it's both. And I'm asked often, well, how do you use both together, right? How do we make that happen? Well, first of all, you need to understand all the different models that you have a choice of. And from a sovereign AI perspective, an open model is really what you would like to deploy to ensure that you know what's put into the model, you know the origin of the model, and you can then add your own data to the model to customize and make it your own. And NVIDIA's open models are called Nemotrons. So we have Nemotron Nano, Super, and Ultra. They are the most open models that you can find. So we not only provide the open models with the weights, but we also provide the data. We provide the recipes of how we created the model. We provide the framework to allow you to create a model using those recipes. And we provide the tools to allow you to do the reinforcement learning through our RL Gym to customize that model. And many people are surprised. If you look at the chart in the middle, you can see from Hugging Face, NVIDIA has provided the most number of open models into Hugging Face of any company in the world. And they're not just for large language models. For example, we have Clara, which is a healthcare-oriented model. From a sovereign AI perspective, you really want to start with something like Clara as you think about your own healthcare needs of your country. Right? Earth 2 is a digital twin of Earth that we're creating. And as part of that, we're delivering models that allow you to understand and predict the weather better. Right? Sovereign nations need to understand the weather specifically in their geography and in their climate, right? For disaster planning, humane recovery, et cetera. Of course, as I mentioned, our Nemotrons, that's where you really want to drive in your language and your culture. Cosmos is a physical AI model. We have Groot, which is a robotic AI model, which can help drive your manufacturing. And then, of course, we have our Alpamayo models, which are how we drive, to use a word, how we drive self-driving cars. I'm not quite sure how that will work yet in India. I'm still getting used to the traffic myself. But we do provide you with all of the tools that you need in order to take those models and use them. And all of these models, I showed you that graph of the the green line where the open models are catching up to the frontier models. That's happening across every one of those models that I showed you, whether it's around intelligence, efficiency, automatic speech recognition, optical recognition. NVIDIA is topping the leaderboards. So I want to start to wrap up the application section by talking about agents, right? So agents are no longer single model chatbots. Agents now have the ability to perceive, to reason, and to create a plan to take action. And in fact, we're in kind of the first phase, if you will, of agents. And agents are able to, when they make that plan, they're able to take that plan and they're able to call other tools to support the agent. However, we're seeing that we're able to now modify them as we start thinking about state-of-the-art agents. So I mentioned earlier that it's frontier models and open models. So agents now are incorporating routers. And routers are what allow you to select the model for the job, the hammer for the nail, the screwdriver for the screw. And so a model can route based on many different criteria. It can route based on intent. Is this a shallow learning or shallow research where I'm doing a quick answer? Is it deep research? It can route based on cost. It can route based on privacy. And it can route based on customization. I want this query to go to my custom healthcare model, as an example. Right? And agents are continuing to get smarter and smarter. There's now the idea of a concept of what's called a skill for an agent. So no longer does an agent have to call a tool. It can call a skill. And in fact, many agents now are creating their own skills because an agent has the ability to create code. So rather than asking an agent to look through a registry of skills or tools, we can tell the agent to do what it thinks is right, and it will just create a tool. Right? It's kind of like if I was just picking up a piece of wood and creating a hammer. An agent can code its own skills, its own tools. And to do that, it requires access to your file system so it can save those skills. But more importantly, it can also, with the proper permissions and acceptance, read in the data from your local file system. And when it writes that code in a secure sandbox so that you know that the code can be validated, verified with human in the loop, depending on the code and the permissions you set, to ensure that your system is accurate and secure. So again, we're seeing every application is agentic based, whether it's enterprise or sovereign. And so if I bring this back to where we started, right? AI is a 5-layer cake. It starts with energy, starts with the shell, the location. It moves up through the chips, GPUs, DPUs, CPUs, networking chips, a full co-designed AI rack-level system that allows you to create infrastructure for an AI factory and for an AI data platform using a combination of frontier and open models to drive agents that are smarter, more skilled, and can do more activities to support you, whether you're an enterprise or sovereign AI. Thank you very much.
Thank you, John, for unpacking that amazing. No? Okay. Thank you, John, for unpacking that amazing building blocks of tokenomics, how we call it as, and how we leverage NVIDIA's stack. No? Okay. I think they switched it. Thank you. So thanks once again, John, for helping us with that building blocks of tokenomics and the building blocks of NVIDIA's that are open platforms, having from data platforms to building these agentic AI stuff. Now that we know how to build these factories, operate them at scale, and how to build these agentic AI platforms using these AI factories, let's learn what the nations can do to have their sovereignty secured by themselves. I would now like to welcome Callista on the stage, who is a Vice President for our AI nations, and she will be covering up on what India is doing it in general, and of course how nations are trying to adopt sovereignty themselves to have their destiny, defined for the citizen services and other platforms. Welcome, Calista.
There must be a lot of very exciting sessions going on at the same time. So thank you for sticking around. And I am also very excited to know that these are being recorded and live broadcast. So for those who need to catch up with this later, no worries at all. I'm super excited to be here at the India AI Impact Summit. And I'm emphasizing the word impact because we're going to get to that by the end of my talk. I would love to share with you a little bit about sovereign AI for nations, which is something I get to talk to countries and developer networks and all of the ecosystems around the world, especially here in India, every day. And it's an exciting new space for us and everyone as we embark on sovereign AI for nations. We're going to talk a little bit about why this is so important, what it is, how we're getting there, and then ultimately the impact and potential that we see going forward. So first of all, why? Why are nations embracing sovereign AI? And why is this so fundamental to where we are headed today? It really boils down to some very simple dimensions. Every nation is facing challenges internally. Challenges around labor, challenges around education, challenges around finding the right talent to kind of surround the work that it has in front of it, challenges in finding the number of workers it needs in shrinking labor forces, challenges in handling bureaucratic processes, document filing, and other things that seem to be absorbing too much of our time. We are meant as humans to work on higher level activities. We'll just put it that way. So that labor shortage is leading us to look for new ways of automation. And we've seen this throughout time, right? We've seen this as we adopted computers and more programming and more applications, enterprise software to streamline our work. We've seen this in agriculture as we adopted new tools and resources. We've seen this in medicine as we've adopted new ways of treating illnesses and diagnosing ailments, right? So there are all kinds of progressions we've seen throughout time, and this time is an inflection point where technology has all the promise to help us overcome many of the challenges that we're seeing. These challenges are so significant. We're seeing the burden of these challenges looking at $7.5 trillion. That's like 5% of the world's GDP. And so there's no better time than now to embrace sovereign AI as a way to overcome those challenges, especially when you're looking at a country as important as India, where we see, looking at population scale ways of doing things, this is the place to do it. So let's unpack, what does it mean? What does sovereign AI really mean? It's not just a technical discussion. In fact, most of our discussions with countries start with the imperative. An imperative means, why are you doing this? Why are you embarking on sovereign AI? What are your goals? What are you trying to achieve? What types of regulations and policies are going to frame the path forward? And what are the development timelines? Who are the stakeholders? And how are we going to embark on this journey together? These are important considerations. These are the guideposts, the maps, and the other elements that are going to take us on that journey together. And it is a journey together, right? We're here to stand beside you. And, we've got lots of maps, but we'd really love for that country, your country, to be in the driver's seat. Second, the second piece is always around workforce. Every country, it doesn't matter where you are on the industrialization path, every country, the US included, is looking at talent for AI specifically. And this isn't just to create a nation of AI developers and engineers. This is to create nations of AI literacy, right? We look at nations throughout time at basic literacy, then at computer literacy, and now we're looking at AI literacy. And that literacy basically means how to embrace AI as a part of every industry, right? So yes, we absolutely need lots of AI engineers and AI developers, don't get me wrong. But we also need to understand what are we applying that AI to, right? So that AI workforce is super important, but its dimension spans the entire country. Third, the AI ecosystem. This is the community, right? This community is so rich in India. We're talking about the developers, the universities, the venture capitalists, the governments, the existing industries, the startups. The AI ecosystem, everyone has a part to play here. Everyone is a stakeholder. Everyone has a voice. And this ecosystem needs to work in concert with one another. Now, every one of these, by the way, is very local. And you might easily replace the word sovereign with local, right? Because that's what we're talking about here. Third, the AI models and data, those are very localized too, whether it's by language or domain or the data or the specific use cases. All of that localization is especially important in order to get the AI output that you're desiring for the specific use case. So these are especially important to localize as well. And then finally, yes, finally, somewhere towards the end of the discussion, we do get to talk about infrastructure. And the sovereign infrastructure is part of the discussion as well. You want to make sure that you are not only harnessing the best capabilities for your infrastructure, but doing the right composition of it as well to serve the use cases for your country, right? So all of these 5 elements come together for sovereign AI for a nation to strengthen a nation. We talked about why as an economic imperative, right? So that economic imperative to grow a GDP, to grow an economy, is about bringing more resource into a country, right? Financial currency, intellectual currency, technical currency. It's about bringing up an economy, right? And that economy has lots of different values to it. And that sovereign AI fundamentally is here to raise that local currency. I could get very philosophical on this slide alone, but we'll keep going. So what does that mean? How does that translate? So my peers, John and Pradeep, have already shared with you and unpacked what goes into an AI factory. I'm going to take this up just a slight level for you. And we're going to say, part of this is the engine for economic growth, right? As we've heard, it's the data and the engine coming in and the energy coming in that provides the AI output that really drives that use case. And that engine for economic growth can come in efficiencies for government, can come as an engine for industry competitive value. And overall, when you talk about a nation laying a foundation, it's that overriding infrastructure that can be used by both governments and industry. It's an instrument for scientific discovery. That scientific discovery can be in medicine, can be in agriculture, can be in industrial innovations. It can be in the many, many ideas that we're seeing across tens of thousands of startups every single day. By the way, you can see a bunch of them that we're super excited about in the NVIDIA Pavilion in the expo area. If you haven't seen them, absolutely go take a look. And you see so many innovations here in India. That expo hall is packed with them, right? And so those innovations are part of the discovery process that feed back into that wheel of economic growth, that help us become more efficient as countries, as citizens. And then finally, a platform for public sector innovation, right? How many of those processes, how many of those bureaucratic processes can we overcome through AI? This is something that often is going on already behind the scenes, that we're reaping the benefits from already. So how is this translating into the progress that we're seeing in India? This is coming in basically 3 different large parts. So first of all, the India AI mission. This is something that the rest of the world is looking at as a model. This is something India can be exceptionally proud of, right? India has taken strides in looking at their mission from angles of education, from angles of public sector innovation, from angles of industry support, from angles of laying an infrastructure that serves both public and private sector needs, from angles of near-term early results to the long-term strategic outlook, from the angles of investing in local models, from angles of seeding the startup ecosystem. India has unpacked the full paradigm of what it means and what it takes to be a sovereign AI, gold standard. I am so proud when I get to tell the India story elsewhere, and probably India can tell it better than me. I am not going to deny that. But this is something that NVIDIA is incredibly proud to partner with you on. That AI-ready workforce, we've seen more than 50,000 certifications. We're working with 500 different institutes. We're working with, I think, all of the IITs at this point. And we're seeing some fantastic results. India has had a spirit of innovation, a spirit of entrepreneurship for many, many years, for decades. And this is something that we're seeing as just as alive in the AI transition. And we're seeing this transpire in the AI ecosystem as well. You see on the expo show floor, you see in the news, you see in every headline, the number of AI companies and innovations coming out of India is absolutely astounding. And the government and industry, the public-private partnerships that are going on in India, I have seen nothing like it anywhere else. This is something you can be incredibly proud of. And you're clapping for India, not for me, I know that. So let's talk a little bit about, just one more layer on that sovereign AI technical foundation. I know my colleagues have talked about this a bit already, but something that nations think about when you look at how that translates to the investments that public sector or governments make into their sovereign technical foundation, because you lay the infrastructure sovereignty, right? So that's understanding your energy, your supply chain, and other elements, right? And you also look at this from the model angle, and we looked at frontier models, open models, and then how you fine-tune those. And then you look at that from the software and the tooling angles. And through all of these sovereign models, I want us to keep one very important thing in mind. None of this means start from a blank sheet of paper. None of this means start from zero. This always means in every case that someone has a blueprint, an open model, somewhere to start from, right? NVIDIA has like hundreds of blueprints, like 400 plus libraries. We're here to help you get started, right? We have been, alongside many startups in the ecosystem, many universities and researchers. Let's use the best practices from around the world and bring those together and get that running start. Because sovereign does not mean isolation, right? Sovereign, the best solutions come via collaboration. Collaboration means that you are gluing your solutions in with a local base where you're investing locally, but you're engaging globally. That global engagement opens doors to developer networks, global developer communities, global supply chains, and global markets, right? Those global markets where you find and grow your businesses. So that's super important. Local investments, global engagements. So these public sector use cases that we're talking about absolutely need that fine-tuning, with the data that's available locally, right? That allows you to bring more fidelity to the outputs that you're seeking, to the up-to-the-minute information. I mean, think about the information that you're relying on through your public sector use cases, through citizen services, whether it's looking at payments, whether it's looking at health data. You need absolute accurate information. And this domain-specific knowledge is coming through many of these data sets. And so that's absolutely critical and required for many of the applications that we see happening today. So what are some of the results here? And I'm proud to say this is one of those slides I have to keep updating because there's just so much going on here, right? And it's, you know, yesterday I had the privilege of joining a couple of different panels and a couple of different panels the day before that. And so I've even updated it across the last couple of days, right? So I look at the work that Sarvam is doing. World-leading biometric identity. Millions of people are leaning on this daily, right? More than 1 billion citizens. What are we at? 1.4 billion citizens in India today, right? Biometric identity that is helping us to drive the financial payments, right? Helping us to drive an entire suite of things that we can then build off of. Bhashini. Never mind 22 languages, now we're up to 36. I mean, geez, at this point, we might even get to 200, right? There is nowhere else in the world that is on a clip this tremendous, right? In one of our panels yesterday, we saw that live translation in motion as we were speaking. It was really profound and it really meant a lot, I think, to all of us, right? And so that is where we start to bring everyone into the boat together, right? That is where we see potential for all 1.4 billion people to come with us on this AI journey, right? This is not something that is going to further increase a digital divide. This is something that can stitch that back together. And so when we look at ASR or something that can be a speech-first application, these are some areas where we have so much more potential now with AI than we have in the past. We look at Zoho. Zoho is a global enterprise software, right? This is something built in India that is now seen globally, and we're continuing to see growth there. And Bharatjan as well. So many areas where we see a ton of pride. Bharatjan is up to 22 trillion tokens. This is incredible. That's another one of the statistics that I got to update yesterday. So where is this going? What is the impact? India AI Impact Summit, right? The important thing that PM Modi said that we are going to focus on with this summit is what is the impact? What is the real life difference that we're going to be making with AI, right? So this is some of the things that we're seeing in public sector. Around education, adaptive learning, tutoring, ability to reach populations and students with learning that's going to really help move them forward. AI that can make teachers better teachers. That's AI literacy, right? Those teachers don't need to become AI developers, but we need AI developers to help build those applications. Urban planning and smart cities. Again, traffic, traffic would be amazing. And by the way, traffic could be amazing in every city I've been in. But smart cities, right? How can we design and make cities the best places to live? Looking at personalized civil and citizen services. Citizen GPT, right? How can you walk into any public institution and know that your information is ready to go, right? You're looking for a license, you're looking for your information specific to your public health needs, all of that. How do you make sure that's ready to go? It looks like my time is ticking away. Geez, I feel like I just got up here. Climate, how can you foresee and simulate future weather that could determine how you route water if it's going to be a flood area, wind if it's going to be a wind area? How do you anticipate that and build for it? Compliance and enforcement, again, how do you kind of automate some of these processes? So a lot of impact that we can have on citizen lives. So I'm going to kind of wrap it up a little bit here. Overall, we work together. We build models. We take the best practices from around the world. We team with you because our goal is to help India become a stronger India, right? And because, we are together on this. And that comes from building infrastructure, cultivating the best in India for India. We work together with Yotta for many years now. And we're very proud of the work we're doing with Yotta as well as several of the other providers. We work together on expertise through DLI and other training and learning, working with universities with training kits, on cultivating that ecosystem and that community that continues to feed and foster the startup ecosystem as well as plumb into existing industries. And then finally, programs. Programs built to kind of connect all of these moving parts. Connect these moving parts so that we can benefit from one another, so that we can learn together and grow together rather than work so independently. So I'll leave you with a few final thoughts. India has the innovation, the drive, the potential, the track record, and has already laid the foundation for so much success that it is my favorite example that I carry with me around the world. NVIDIA has so many capabilities that we can help bring to this great partnership. We have resources to bring to developers to help accelerate this journey, and we're so excited to do that. And, every country we speak with is excited to embark on this AI-driven era. India is laying the groundwork for that. And every startup that is born in India is not there saying, I only want to live in India. Every company is saying, I'm a global company, right? Every company is saying, I want to be Zoho, I want to be Tata, I want to be a global company. And that's something that I'm excited to say, AI has the potential to help grow those companies from India. So again, I'll leave you with that last idea. Keep investing locally, but always engage globally. Thank you.
Thank you. Thank you, Calista, for that amazing example of how sovereign AI can be built in a country and what a country can transform its citizens to adopt option to transform. Over to you, Shankar.
Thank you. Thanks a lot, Jigar. It's such a pleasure to be here back in Delhi, where I started my career almost 40, 50 years ago at IIT Cross and House Khas. I'm going to share with you my framework for how we take all of this goodness which Calista and John and Pradeep talked about, and apply it into industry. Apply it in industry not just for India, but also for the world. In other words, there's an India for India story here, and an India for world story as well. So let me start by kind of talking about the 3 pillars of AI. First of all, there's the digital or the agentic AI, which John covered quite comprehensively. It's about billions of people and processes working in a digital world using perception, reasoning, generation, creating intelligence from the data that we have in our digital economy, whether it's retailing, financial services, and all of the other digital industries and services that we have. Second is the physical AI. And the physical AI consists of the trillions rather than billions of machines and sensors and cameras and robots that are going to be working in the physical world, obeying the laws of physics and chemistry and biology. And it becomes, instead of a two-computer problem in the digital world, a three-computer problem, because the brain of the robot needs to be simulated in another AI factory. So the brain has to be generated in one AI factory and then simulated, tested, and certified in another AI factory before you set it out into the physical world. So that's the physical AI. And then, of course, the combination of this digital and physical world is in what Callista talked about, which is sovereign AI. And sovereign very much matters because if data is the raw material or the fuel for AI, you don't want to be exporting your data and importing your finished goods, in other words, your intelligence. So sovereign AI is super important. And these three pillars of AI are in the economy and the industry. So let's first talk about AI agents in every industry. So we at NVIDIA are working with all of the major corporations in a handful of situations in all of the leading industries. We have roughly around 17 fully fledged industry teams now in all of the industry verticals, and it'll shortly be growing to 21 or 22 teams globally, everything from sort of, agriculture all the way to zoology, if I may say, the A to Z of industry verticals. And in every one of these, the architecture that John described is now being verticalized for the specific business problem that that industry is addressing. So, for example, our retail team just put out a shopping assistant blueprint, which could be used by a large corporation globally, or an e-commerce company like Flipkart here locally. And these blueprints are all open source. They're all publicly available. They will run on any AI factory internally in your company, a private AI factory, or the public cloud AI factory on the same reference architecture. So the financial services team, our payments industry vertical, just put out a fraud detection and fraud prevention AI, agentic AI blueprint, which is being used again by many of the payment processors, both here in India as well as globally. And notice that payment processing blueprint, which is used in the financial services industry, can also be used in the medical and health insurance industries, for our Medicare in America, or for, Ayushman Bharat payments here in India. So that's another example. And I could give you many other examples across all of these industries. For example, for smart cities and warehouses and factories and spaces and stadiums and temples, we have the world's best video search and summarization blueprint. It is one of our most downloaded blueprints. We have hundreds of thousands of corporations using it. We have 140 ISVs which have adopted it, and so on. And again, in this agentic AI space, all of the leading ISVs are starting to put out these agentic AI software applications and blueprints. So we're working with Amdocs in the telecom industry, with SLB in the energy industry, with Schneider in the energy industry, and so on. So there's industry vertical instantiations of these agentic AI applications. The second area, which is the area that Callista talked about, is the sovereign AI. And here, especially in India, population scale matters. So we're not talking about a small number of identity transactions going on. We're talking about billions of transactions happening every week on the Aadhaar system. And I'm really proud that Jigar's SA team, working with our National Informatics Center developers and integrators, have now, I think we are accelerating around 50 million identities every single day using the AI factory architecture that we have proposed here in India. Another very interesting one is the NCPI processing 700 million payments on accelerated computing now. Using this same AI factory architecture. And then I think one which might be near and dear to some of us who are working through the backlog of the courts. Once again, the AI, the National Informatics Center has now rolled out their judicial processing system to 625 courts and 20,000 judges. So hopefully we can start to clear out the backlog in the judicial system right now. And it's work that the country should be proud of. You're using an industry standard architecture. The developers and the architects and integrators from the National Informatics Center and from our global systems integrators who work here in India are able to do this seminal type of work. The other thing which is happening here is, I think Callista already talked about the Bhashini, so it's really cool. I mean, I was at the Rajasthan DigiFest in January, and the talks were being simultaneously translated and transcribed in multiple languages across the screen in real time. And this work is again being done by our technical people working with the Bhashini people to make this happen. And I hope that as a result of the investments in infrastructure that are being made here by the data center companies and by the Indian AI mission, we will have much stronger foundational models in India from the likes of Sarvam and all the other, Gyan and so on, the other companies. BharatGen is another very good one, all building up foundational sovereign capability in terms of LLM, including, by the way, physics-based real-life LLMs as well. So, the third area, which is building physical AI. And here we are working with all of the global industrial ISV companies, the likes of Cadence and Synopsys, which acquired Ansys, and Siemens, which has Siemens Digital, and Schneider, and a whole bunch of, Jensen was at the Dassault conference just a few days ago, integrating that reference architecture that John showed you with Cosmos and Groot and Isaac into their ISV offerings so we can build better factories, we can design better products, we can implement better physical AI systems across this country, our country, as well as globally. In fact, Bobby Mitra is going to be talking, I think, next in an adjacent session on how they are using Omniverse to make a 4D simulation of the Tata Electronics fab, which is being built right now in Dholera and in Assam. So that's using our software architecture. I'm also very happy to say that companies like Infosys and Wipro are also embracing this physical AI and automating retailing and gas stations and warehouses and factories so that they can be better automated with or without robots in the architecture. So those are the three basic pillars: the physical AI, the sovereign AI, and the digital AI. Applied across all of the industries. And you can go to build.nvidia.com right now and look in there. You can scroll down to it starts with, our basic capabilities. If you scroll down to the bottom of the page, you will see a button which will take you to all of our industry-specific blueprints that we are providing to the entire community so that you can start to immediately build and deploy these types of agents at population scale in India or elsewhere. And the bottom line is every enterprise, every government department, every public sector entity, every school, every university, all of you need an AI factory built with the architecture that John and Pradeep talked about. I am particularly passionate about, especially now with the new tax holiday for data centers. We have 1,800 global capability centers in India, from all the Global 2000 corporations, 1,800 of them have a major global capability center in India, currently employing over 2 million people, shortly to grow to 3 million people employed in these centers. And every one of these global capability centers needs their own local AI factory from which they will take their data, their business processes, their IP, and convert it into intelligence. And so this is a very big opportunity here in India. And as we described, this is foundational infrastructure. So the good news is, you know, we have roughly about $1 billion, $1.2 billion, depending on the exchange rate you use, of investment going in from the government into AI infrastructure in India. And it's commendable, it's deployed. Around about 38,000 of our high-end GPUs are deployed in this AI mission infrastructure. And we're very happy about it. It's being highly utilized. But to put it into context, the overall investment per year in core infrastructure in India is now of the order of $150 billion a year. And we need that infrastructure. We need the roads, we need the bridges, we need the railway, we need the high-speed train, we need the airports, the seaports, the electricity grid. And of course, that goes into the 150 billion a year. But the amount being invested at 1.2 billion for the AI mission is still insufficient to actually create that population scale AI and put India on the manufacturing map, on the services map, not just for India in India, but for India into the world and providing that. So I hope that we will be able to, as the economy grows, put more investment into this AI infrastructure. So having said that, let me bring up all of my colleagues back here on stage, and we will be delighted to take a few questions. I think we still have a little bit of time, and we would love to take your questions and address any concerns and whatever you may want to bring up here today. Okay, let's get back up. Who's going to ask the first question? And how, what's the system? Oh yeah, there's a microphone here. I think we've got some hand mics. Jigar, you need a mic? Are you sure? Yes. Okay.
Thank you so much. My name
introduce yourself at least. Short in 15 seconds, okay?
No problem. My name is Gaurav Jain. I'm the Director and Head for Artificial Intelligence for Pfizer in APAC, India. And my questions relies on great capabilities that NVIDIA is building. How about we are talking about some of the decentralized data and how can we integrate that into our day-to-day enterprise-level systems?
What's the question again?
We run a lot of clinical trials. The decentralization of the data becomes very critical for us.
Okay, Pradeep.
Okay, so, you know, your data can be at many, many different places, right? And that's exactly, you know, the kind of the problems we always deal with. I think the data can be structured and it can also be unstructured data. A very simple way, right now we are working with a lot of our storage providers, right? Think of we are creating what we call as an AI data layer. So where you can go and talk to your data, right? Think of it's a capability which is built in collaboration with a lot of storage providers. Like I think John talked about a couple of them earlier in his talk, right? So that's a way. Like if you're talking about more of a graphics data and other kinds of the data, like we also have like, you know, Omniverse as our another platform where you can bring in all the data and we convert that into the USD and bring it in something called Nucleus, which is kind of a one way of putting all this data inside it. And then you can, from that, go and visualize all that data within the Omniverse. But in the reference of like AI and then structured, unstructured, we're working with the ecosystem of all the storage providers. John, do you want to add anything?
I was going to say, once you have your data, you know, if your data is distributed, as long as you provide the right set of APIs, the agent will know where to go get that data, and the agent can get that data. So you're basically federating your data at that point versus having to try and move it and bring it all into a single data lake.
No, and thank you so much for the skills that the agents are bringing. That was a wonderful point. I appreciate the answer. Thank you.
Okay, let's take some more questions.
So very good morning. My name is Siddhant. I'm a startup of climate tech. So my questions to NVIDIA, like how leveraging AI to contribute towards poverty reductions, and are the specific programs, technologies, or partnership focus on improving livelihoods in how low-income communities? So my questions to all of you.
Yeah, I'll add some of the data points, right? Let's take a very simple example. I think Kalista just covered that pretty well when she was giving the examples. Bhashini, right? Today, my mom does transactions in SBI using her local language. That was a barrier. At NPCI, the amount of fraud that takes place for the country in UPI transactions that we do has started to reduce significantly. And that amount, something I can't disclose it because that's not disclosable data, but that data is significantly large. It's in millions, hundreds of millions of dollars per year, right? A small shop guy who's doing a transaction, losing his money on a fraud, is bringing them back towards the poverty, right? These are the gaps that we are trying to bridge in. I think there's a nice announcement that government has done during the budget, which was for the farmers, call it as Vistar. The first deployment is taking place in Maharashtra, call it as Mahavistar. That's for anybody and everybody to call up on a phone, talk to an agent, which is basically AI in a local language, asking and telling, how do I start my farming and what are the schemes that are available? And can you auto-apply it? And can I get the benefit, direct benefit transfer to my account? Or tell me the nearest place where I can buy and sell the things that are needed for my farming. Every information will be available on just one phone call away, right?
Let's do one question from there.
Hi, my name is Indranil Dabhade. I'm the founder of Automation. My question is regarding to big tech. Now, since the supply chain from NVIDIA is basically involves the big tech, and India itself has got their own big tech in Infosys and all, a lot of startups coming up with AI, if they wish to join the supply chain for NVIDIA, the feasibility of these startups joining and the process of NVIDIA evaluating the solutions that these startups are offering towards NVIDIA.
Okay, why don't you give the microphone back and we'll answer the question.
Yeah, I can take it up.
Okay.
So we have an Inception program. I think I have seen India team doing pretty efficient job in 48 hours to 7 days maximum. You get a response with details. Once you get selected, which I think is quite liberal, what I've seen it, because we have over 4,000 startups as we speak in the country today in our Inception program. You get your GPU allocation done. That's free for a certain duration of time with certain credits. That's one way to look. The other way to look at it is, I again go back to what I think Kalista and Shankar announced it. I think India AI Mission has some amazing work done on bringing down the cost of GPUs from the country for the country, right? Startups can now avail that similar prices that cloud providers are able to offer it from the country, actually.
I'd like to add just one additional thought there, and that is that for those who've been working with NVIDIA, we do everything through our partners. So I think, if you're looking for an engagement directly with NVIDIA, that is not the only path. Becoming a partner to NVIDIA, if you're, an established, hardware, software provider, or becoming a partner to one of the local providers, that's how you start to create that local community, right? So, consider how do you ingrain yourself in the local tech ecosystem that is about that AI solution that you're proposing.
Okay, so we'll take one question there and then hand the mic over and we'll bring it over here. Okay.
Okay. Thank you so much. My name is Srirang. I'm a student at Ashoka University. My question to you essentially is that if India sort of does invest in building all these infrastructure and building sovereign AI, how can it ensure that we avoid any bad incidents and to make sure that we ensure AI safety?
Sure. Why don't you take the mic and then let's bring it across. Who wants to do that? Public safety.
Okay.
Yeah, okay. So you basically touched on the 2 points, right? One is building the infrastructure, right, as you are building. Yes, think of it's a foundation piece. What do you need to drive the next industrial revolution in the country, right? That's a very simple way of thinking about. And then your question was more about the safety, right? And then ensuring that, the AI which you're creating do not have the biases. I think that's a very active area, right? Because anything which you create, it's not only just starts from the AI as an algorithm point of view, everything starts from the data. That's why, like, if you look at NVIDIA, in our open model strategy, what we have done, we have not only open sourced the models, but we have also open sourced the data, right? We also have tools like guardrails, by which you can go and ensure, hey, what's being, communicated through that AI. And then you can also put on the top of the additional safety and the security, right? Because any enterprise where you're going to deploy these systems, you need to ensure the right guardrails and the right security is being put in place so that you can see the right uses of this technology, right? So think of it's a combined responsibility of the developers of this technology, the users of this technology, and then ensuring even the government has the right policies so that we all can work together to nurture this ecosystem.
I just want to add one real quick for the student. So if you're a student, right, all of our technology is open source. So our whole NEMO framework, there's everything from data curation to synthetic data generation, where you can take small amounts of data and generate synthetic data that is secure and safe, but uses the same attributes of the data that you started with. So it hides PII and all of that stuff. Right? And then we also have an ecosystem of partners that we work with that can secure data at different levels. And so if you haven't, Shankar called out earlier, build.nvidia.com, you can find blueprints there that actually show you the Jupyter notebooks on how to deploy some of these technologies.
Hello everyone, my name is Nikhil Mathur. I am from National Internet Exchange. Sir, I wanted to talk something about the application of AI in critical infrastructure like in industries. Sir, I understand that in industries the processes are very critical. I myself have handled the calibrations, everything. I wanted to add something. Can human interface be built to check the decision level of the AI systems? Or how can I research in that topic? I wanted to ask.
Yeah. So, you ask actually, again, the multiple questions, but just to answer your first question, can industries leverage AI in the critical infrastructure? The answer is yes. Think of like a very simple example like oil rigs, where you even today go to the humans and it's a very dangerous conditions there. Can you go and deploy the robots there? Yes. Putting the humans in the loop? Yes, of course, yes. A lot of systems, like think of healthcare is a great example, right? Where you can go, like think of simple scan, a radiology scan, where you can go and AI can give you some initial output, but you still would like to have human in the loop to have a second opinion on that. So to answer that question, yes. Most of the systems today are being built. They are like, even the agentic systems, the companies and the enterprises are thinking to put the humans in the loop at certain point to do the right validation or to ensure that, hey, as a part of this entire flow, we have somewhere like where humans are being involved, right? So both the things, the answer is yes, and that's how it's being done.
Okay, let's take a question from there.
I'm Avisha Chaudhary. I'm from Ashoka University, and I'm researching in enterprise compliance. And thank you for the enriching session. And you also talked about, Pradeep sir, that you have guardrails when you deploy certain sovereign AI capacities via NVIDIA. But the thing is that today we see employees bypassing enterprise blocks through the public LLM models, which are deployed online. So there is no certain way to secure your data leaks through the online model. So is NVIDIA looking at that aspect as well and trying to deploy security?
Yeah. Okay. So I think one interesting part is that this field is evolving so fast, right? If you see the amount of the tools and these things are coming, which are open source. People can download, use it as a PC, right, on your normal laptop, and can go and create your own chatbots. When you do that, you kind of put your data at the risk. If you give an exposure of your data without putting the right set of the security and the guardrails in place, right? So generally, the way, I can give you an example, the way enterprises are doing, for example, any of these open source models, right, or open source tools which are available, they generally have a local sandbox, right? Think of that way, which is like being secured through their own enterprise authentication. Like you might have heard of like single sign-on kind of a thing, right? You as an individual, if you go and download something and you expose your email to that, I think that's your responsibility. Again, think of exposing your data for your personal usage is your responsibility. But at an enterprise level, every enterprise actually goes through these sandboxing, these checkpoints, single sign-ons, so that only think of the agentic systems. I think John talked about, not every agent will have access to every data. There is a access control which is being provided to each and every data.
Okay. I think you want to probably add something here.
No, I'm good.
Okay. Let's take a question there. I mean, the key point is that open source. That's why John emphasized open source. Okay, that's very good. Okay.
Thank you for a very good session. So my name is Vinay Jirgale. I represent Trimiti Innovation. So we work in the digital twinning space. So my question is, and we are working with the MSME industries, and we want to take the benefits of Industry 4.0, digital twin, whatever possible to that level. Because if the MSME grows up, then the overall Indian ecosystem will grow. I'm also working on the tier 2 and tier 3 and want to take this Omniverse. So current challenge is Omniverse needs heavy GPUs and they can't afford buying such costly GPUs. So through cloud or some other means, can we reach to them and can
yes.
they
So I think we have our cloud providers from the country who are giving this solution and Omniverse on cloud at a much, much cheaper price than the global price that I have seen it. I think Yotta is a good option. E2 is another good option. Tata Communications is another good option. You could go to them and ask for Omniverse license with a GPU, and you will find the price which is going to be very, very effective.
Okay. Next question over there.
So hi. Very good morning. My name is Ahid. I'm a counselor for AI, data, and open source. So I assume that through your engagement with regulators and policymakers, you are seeing in early signals of how legal standards are evolving. So do you expect some sort of convergence or some sort of fragmentation in AI regulations happening like in the world, in the US and in India? So is the convergence or the different side?
Who wants to take that?
Sorry.
So predicting the regulatory environment is it's hard. It's really hard to predict. It's absolutely difficult to predict. I think that different jurisdictions are taking various approaches to it. We're very excited about the approach that India has taken. It has fostered a very innovation-friendly environment for the developer community. In fact, one of the tenets that I've seen in India in particular is it's been very inviting for startups to stay and grow here. And that is something that is testament to the resources available, the government investment available here, and the general supportive environment. And that's something that regulation has an impact on.
Okay, we'll do two more questions. Gentlemen here in the front. I would actually like to do we haven't had enough ladies ask any questions. So anyone?
There we go.
Okay, so last question, we'll take a question from the
Thank you very much. My name is Hari Mulakutla. I run a responsible AI leadership consortium in New York, and I'm an advisor and a small investor in Fiddler AI in the guardrails column. And my question is a very broad one. When a lot of people talk about human in the loop, increasingly in terms of coding or any of the expertise, AI systems will soon have more expertise than humans. So who are these humans? What expertise will they have very, very soon? As you could see, very less people are going to learn how to code. So how can you trust that these AI systems are going to do right for humanity? And NVIDIA has answers for everything. I would love to hear what you guys have to say about that. Thank you very much.
Well, okay. I don't know that I can speak for all of humanity. However, I do think that some of the questions you raise, in particular around coding, you want human in a loop to ensure that the activity that's going to be taken is something that should be taken. So we have human in the loop. Even at NVIDIA, all of our engineers have access to, Cursor, Claude Code, all those tools. But every time you use it, it will ask you, and it's based on the settings that we set and the sandboxes that our IT has set up. So like I use Claude Code, even though I'm not coding. I use it as a general purpose AI. And every time it tries to execute a command in a bash shell or something like that, it requires me to approve it. So I'm in the loop that way so that it can't do something destructive to my local system or local data. And ideally, I would have it execute this code it's written in a sandbox before I allow it to commit a PR.
Okay, we'll take two last questions because the next session is going to start. The lady here and then followed by the gentleman over here. Okay?
Hello everyone, I am Dr. Meghna Kore from Maharashtra. I am an educationist. I would like to partner with NVIDIA to build a complete ecosystem in education sector. So how I can initiate with you all. Thank you so much.
We can connect offline.
Thanks.
Okay, Dr. Jigar, last question.
Yep.
Hello. First of all, thank you so much, dignitaries, for giving me this opportunity. My name is Adil Sheikh, and I am proud alumni of Prerna ELP initiated by Ministry of Education. And I am an undergraduate student and global delegate. So, sir, I question for you, what a role can young innovators and students play in shaping sovereign AI system, and how can government make infrastructure more accessible to grassroots talent?
Did anyone get the question?
So there is a noise. How can government make more?
Make more accessible to grassroots talent.
Grassroots talent.
Grassroots talent.
I think India AI mission is a classy example of how it's getting made available to the grassroots people.
Okay.
In my view, in the at least history of what I have known from the last 21 years I've been working in India,
yeah,
I have not seen government giving so much of infrastructure availability on digital side to these startups and researchers in one go in a year's time frame, right? And I'm sure from here, it's just the beginning. Yeah. It's going to explode from here, as how the announcements I hear yesterday as well, what Minister has made it. My view is, it's just the beginning and more is coming our way.
Okay, thank you so much, sir.
And that's the reason to think of it as infrastructure, just like, electricity, water, roads, etc. Over time, they become more available to the entire, community within a country.
Absolutely.
Okay.
So thank you all very much for joining our session today.
So much.
Thanks to our panelists, and have a really good conference.
While they set it up, I would still like to encourage all of you to visit NVIDIA booths.
Oh, yes.
We are celebrating our success of our partners who have worked with us for the last 5 years in building this journey of AI infrastructure and AI application at scale. We also have all the foundation model players of the country announcing their new models in other halls starting 12:30. Please do also join them. Thank you.
The next session will begin in about 10 minutes, so please take your seat if you want to also participate in the next session.